Let's start the practice with something relatively simple. In example 1, we need to evaluate the integral of x sine x dx. What is the strategy to in solving a problem like that we have some kind of product and we think that integration by parts is the technique? You go ahead, Manny. Say it again.
We split it up into two separate intervals.
Two separate. I would say instead of integral, to separate two different functions. One will be probably u and the other v. Look back at the result of the rule here. Okay, here is on the left side. You can see it. We are looking on the left to have an integral of u dv. And then if we have an integrand that looks like, integrand that looks like u plus the variable of integration dv, then we know that on the right side we have u times v minus the integral of v du, which hopefully is a simple integral that we can calculate. So this will be something we don't know right off the bat how to calculate, but if we choose cleverly u and v such that this integral, the integral of v du, is simple enough, then we have a way to solve it. So we need to start by assigning, we want x sine x dx to be u dv. So we're going to say let u equal something, let's dv equal something else. Now, this thing will be the first step in calculating, evaluating integral by integration by part technique. We need to establish u and we need to establish dv. So what would be your choice, folks, of u, and what would be your choice for dv? I'll let u be x and dv will be sine x dx. Why is that? Because I'm looking at this list and I see somewhere I have sine x dx that I can deal with. Okay? I know it's negative cosine. So it's on the list, and let's see how this happens. If this is the choice, I also, looking back here, I have two other components. I need to have u, I need to have v, I need to have dv, and I need to have du. Okay, so if u is x, then du is simply dx, right? And if dv is sine x dx, then v by itself is the antiderivative. Again, I'm looking here, it will be negative cosine x. And for the time being, let's put the c aside. We're gonna tack it on at the end. Okay? So I have all the four components in place. I'm going back to what I have here, and I'm going to say that now the integral of x sine x dx in the new dress, after this substitution, will be the integral of u dv. And the result will be uv minus the integral of v du. I'm gonna repeat writing this form because it's one of the techniques that help you remember stuff. If you write it again and even silently say to yourself, you know what, the integral of u dv equals uv minus the integral of v du. And after 2 or 3 times, you got it. It stays in there. So sometimes we need, in addition to learning the concept, also we need to memorize the technique. And right now we are the technical part. Also, we are trying to acquire the skill. So now I need to replace uv and the integral. So this will be equals to u times v, well, it will be x times negative cosine x, minus the integral of v, which is negative cosine x, times du, which is dx. Now, I'm looking at the result, and I have negative x cosine x, and before being tempted to change the double negative to positive, I'm looking to see if I can do with the integral of negative cosine x. So I'm looking here, and the integral of cosine, no, so I might as well do the plus, and the integral of cosine x dx is sine x. And now I'll tack on the c. So let me rewrite it. The result will be sine x minus x cosine x plus c. Here's the question. At this point, how do I know that this is the correct solution? Simple enough. I can check by differentiating, right? So let's see if d dx of sine x minus x cosine x plus c indeed equals to x sine x. So here comes the differentiation. The derivative of the sine is the cosine. And then here we have the little of a product rule. So the derivative of x is 1 times cosine x, right? Minus x times the derivative of the cosine x is negative sine x. Plus derivative of c is 0. So we end up having, let's see, cosine x minus cosine x, double negative here, plus x sine x. Indeed, we end up having x sine x. Yeah, we got the right result. Lucky us. Now, here's the last question. What happens if we choose different u and different u dv? Remember, we start by choosing u equal x and dv equals sine x dx. What happens if we choose it differently? I want to stop here and let you try. I'll do it on the next page on your own. Let's change the substitution and choose different u and v. So now try to solve the same example by choosing different set of u and dv. Okay, and I'll pause here. I'll let you try that and tell me what is your conclusion. This choice will lead to pain and suffering. Let's see, if u is sine x, du will be cosine x dx. If dv is x dx, then the integral will be x squared over 2, right? And now we're going to say that the integral of x sine x dx with our new notation, it will be the integral, of course, of u dv still, and it still equals to uv minus the integral of v du. But let's see, with the new notation, uv will be sine x times x squared over 2, like so, minus the integral of v du, minus the integral of x squared over 2, and du is cosine x dx. Now, you can solve that, but it's more involved. So, although we can solve it, it's a poor choice of u dv. So let's write I can say it's a poor choice. I'm not offending anybody because I suggested that of u dv. All right, so the conclusion is really you need to be a little bit smarter, a little bit careful about the choice of fu dv. So let's move on to the next example.